in last class, we had already studied the golden section search method. Okay, and in that case, we use some value of row, okay, throughout the, and that value of row is your constant one, and you know that what is the value of that. Okay, so that value is approx 0.32. Okay, so here now in this Fibonacci method, basically the this row value is not same for the process. Okay, so if we write here, if we write a note in this manner, so in golden section method, so in golden section method, we use the same value, that is you know that, okay, throughout your process. So, okay. So now suppose that this value is changes at each step. Okay, so now suppose that we are allowed to vary the value row from stage to stage. Okay, from one. So this means there are different values of row. Okay, so that at the kth stage is the reduction process, we use the row value row k, and at this means at kth stage में हम क्या यूज करेंगे, हम यूज करेंगे रो के वैल्यू. ओके, एंड देन नेक्स्ट स्टेप में दिस k+1 स्टेज में हमें यूज करनी होगी नेक्स्ट वैल्यू, दैट इज रो ऑफ k+1. ओके, तो फर्स्ट स्टेप में आप रो 1 यूज करोगे, और इसी तरह से आप फर्स्ट स्टेप में क्या यूज करेंगे, फर्स्ट स्टेज में हम यूज करेंगे रो 1. ओके, एंड सिमिलरली वी kth स्टेज में रो k एंड k+1 स्टेज नेक्स्ट वन. ओके, सो आफ्टर n इटरेशंस, सो अगर हम इस तरह से यूज करें तो n इटरेशंस के बाद आपका जो प्रोड्यूस फैक्टर है इंटरवल का वो कितना हो जाएगा. सो आफ्टर n iterations of algorithm, the uncertainty range is reduced by a factor. It is reduced by a factor, and that factor is in first step this is 1 minus rho 1, in second step this is 1 minus rho 2, third step 1 minus rho 3. So after n stages your uncertainty range is reduced by a factor 1 minus rho n. Okay, so depending on this sequence, what is the value of this rho 1, rho 2, rho 3, so we get different reduction factor. So at each iterations, okay, so you find different reduction factor. Okay, so at each iteration you find different reduction factor row. Okay, that is row of k for different value of this. And how can we find this value of row k? This value of row is basically depends on basically Fibonacci sequence. That's why you know this method is Fibonacci method. Okay, so here we introduce the sequence, Fibonacci sequence. So here we introduce the Fibonacci sequence, and that sequence is written as F1, F2, F3, in general sequence Fn. Okay, so this is Fibonacci sequence, and this sequence is defined as this sequence is defined as follows. So here, first we have this, what is the value of f of minus 1? That value is 0. And what is f0? That is 1. F1, this equals to 1. Okay, so by convention, then for any k that is greater or equals to 0, your f of k plus 1, this formula is usually defined as fk plus fk minus 1. Okay, so here we get here some values of Fibonacci element. So some value of elements in Fibonacci sequence and that values are here f1, f2, f3, suppose f4, f5, f6, f7, f8, and so on. Okay, so here f1 is 1. Okay, so what is the value of f2 here? So when we put in k equals to 1 here, k equals to 1, you get f2. So k equals to 1, this becomes f1 plus f0. So this f1, f0, he adding these two, this becomes 2. Okay, so what is f3? F3 means k equals to 2. So k equals to 2 means f2 plus f1. F2 plus f1. So 1 plus 2, that equals to 3. F4, 2 plus 3, that equals to 5. F5, 3 plus 5, that equals to 8. 6, 5 plus 8, this 13. Okay. F7, 13 plus 8, this is 21. F8, 13 plus 21, that equals to 34. And suddenly you find more values here. Okay. So this is basically your Fibonacci sequence, and the values of that element is 1, 2, 3, 5, 8, 13, 21, 34, and up to infinity. Okay. So here you get here. So here, what is the value of this first one? That is rho 1. Okay, rho 1 is equals to 1 minus fn over f of n plus 1 if we perform our calculation by n iterations. So then the value of rho 1 is this thing. Okay. What is the value of rho 2? Rho 2 is 1 minus f of n minus 2 over f of n minus 1. Fn. This is n plus 1, so this becomes fn. Okay, so what is the value of rho 3? Rho 3 is 1 minus f n minus 1. This is n minus 1. N minus 1 over n. This is f n minus 2 over f n minus 1. Okay, similarly, what is the value of rho n in the last stage? This equals to 1 minus f1 over f2. Okay, so this is the formula for rho 1, rho 2, rho 3 up to the rho n. Okay. And in last step, you see that you in at different stages at rho 1, this value is different, rho 2, this value is different. Okay. But in last row, in last station, you always find 1 minus f1 upon f2. Okay, so where n be any integer value, number of iterations. Okay, so either 2, 3, 5, 10, 100, maybe whatever value you choose. And okay, so this becomes always in last step, this fn is 1 minus 1 by 2. So what is the value of this 1 minus f1 by f2? What is the value of f1 here? F1 is 1 and f2 is 2. This 1 minus 1 by 2, that equals to half. In last stage, your reduction factor is half. Okay, and other cases, your reduction factor is less than half, but they are different. They are different one. Okay, in golden section method, your row method is less than half, row is less than half, but they are fixed in each iterations. But here, the row is less than half, but they are varying after each stage to end the stage. And in last stage, this equals to exactly half. Okay, so now if we perform our iterations, so after n iterations, our this uncertainty range reduced by a factor, this 1 minus rho 1, 1 minus rho 2, up to 1 minus rho 1. So now if you putting these values, 1 minus rho 1 here, 1 minus rho 2 and rho 3 here, so in what factor our uncertainty range is reduced after n stages. Okay, so next page, we putting these values from row 2 up to row n in this factor. Okay, and then we get what is the value of these values. Okay, so here, what is the value of 1 minus rho 1? 1 minus rho 1 is equals to fn upon fn plus 1. What is the value of 1 minus rho 2? This is fn minus 1 upon fn. Okay, so if we multiplying this, fn are cancelled out. Similarly, this and this are cancelled out. Okay, so in next page, so of n stages, the uncertainty range reduced to this is 1 minus rho 1, 1 minus rho 2, up to 1 minus rho n. And this value equals to, what is the value of 1 minus rho 1 is fn over f of n plus 1 multiply. Second one is f of n minus 1 over fn. Next one is fn minus 2 over fn minus 1. And this multiplied, the last term is rho 1, that is f1 over f2. Okay, so here you see that this fn and fn are cancelled out. Okay, then fn minus 1 and fn minus 1 are cancelled out. Similarly, this f of n minus 2, this term is cancelled by next one. And similarly, this term is cancelled by this term. Okay, this equals to here. Finally, you get f1 over f of n plus 1. Okay, so after n stages, you get your uncertainty range is reduced by factor this f1 over f of n plus 1. Okay, so where the any general Fibonacci sequence, say fk, or the elements of Fibonacci sequence so the resulting algorithm is called the Fibonacci search method. This is Fibonacci search method, and the reduction factor is in the uncertainty range for the Fibonacci method. The Fibonacci method is equals to this term, that is f1. Okay, so this means f1. What is the value of f1 here? So if you're putting f1 equals to 1 here, so this is 1 and f of n plus 1. Okay, so this value is because this f1 equals to 1. So this becomes 1 upon fn plus 1. This is equals to 1 over fn plus 1. Okay, so this is a final value. Because f1, f2 are fixed, but this fn plus 1 is not fixed because this depends on number of iterations. Okay, so number of stages. So that's why this fn plus 1 are not fixed. F1 is always fixed. F1, f2 value is always fixed. Okay, so when n is fixed, then fn plus 1 is also fixed. Okay. So now, if we take the same problem that we already done in our golden section search method, and we take same problem and try to find a solution with this method. Okay, so if we consider, function, consider the function, and that is the same function, that is if we take fx equals to x to the power 4 minus 17x minus 14 x cubed plus 60x square minus 70x. Okay, so you have to find the value of x that minimizes by using Fibonacci search method. Okay, and locate this value. Locate this value of x within the range of that range is 0.3. Okay, already in last problem we have taken same thing, but same thing, but we here change our method, that is Fibonacci search method. Okay, so here we have to find the value of n, means in what number of steps the range is reduced in the range of this 0.3. Okay, so after n stages, you know that after n stages, your uncertainty range is reduced by a factor 1 upon f n plus 1. Okay, so after n stages, after n steps, the range is reduced by by factor this 1 upon this thing. Okay, so reduced by factor, and that factor is 1 over fn plus 1. Okay, so this means this is less than your final range, okay, over your initial range. So this is your initial range. So your final range, you have to locate your values in this value, and your initial range is 0 to interval, is 2 by 0. So that value is 0.15 here. Okay, so now thus we need the value of n, means f of n plus 1. This is greater or equals to 1 upon 0.15. Okay, or you say that this value is equals to 100 over 15. So this value is approx 6.67. Okay, and in Fibonacci sequence, you see that what is the value of f1 is 1. Okay, so f2 is 2, f3 is 3, f4 is 302.5, f5 is 8. Okay, so these are your value of that, and here you find what is the value of are greater than that. So this means we have to locate this value, that is f5. Okay, so this means this equals to, this implies your fn plus 1, that equals to f5. Okay, f5 means f of 4 plus 1. So this implies your n equals to 4 here. Okay, so this means you have to then do problem in 4 steps. Okay, so we will do our iterations in 4 steps. Okay, and each steps your values are changes. Okay, so in first iteration we take row 1, in second row 2, in third row 3, and in row last one row 4. Okay, so now in next page, the next page, what is iteration first? Iteration first. So here we start with this 1 minus row 1. Okay, and number of steps is 4, n equals to 4. So this value, you know that fn over fn plus 1. This is the formula, so n plus 1. And here, this n equals to 4 here, so this becomes 5. Okay, because n equals to 4. N equals to 4, that's why this thing. So what is the value of f4? So in Fibonacci sequence, you get 5 by 8. Okay, so this implies your value of row 1 is equals to 1 minus 5 by 8. So this equals to 3 by 8. Okay, so you can find 1 minus value of row 1 minus row 1 or row 1. That's what they say. Okay, so then we compute. We can compute this A1 because you know that this is your interval and all methods are same as golden section search method, but here only this value row is replaced by row 1, right? And all methods are same. So A1 and B1. Okay, and here this reduction factor is not row. Here we take row 1. Okay, so here this row 1 is equals to, you know that what is the formula in golden section search method? This is A0 plus row, and here we write here row 1, and this is the length of your interval that equals to this thing. Okay, so what is the initial point is this thing, and row 1 is equals to 3 by 8, and here 2 minus 0. So this value is 3 by 4. Okay, and what about your B1 point? So B1 point is equals to first point A0, and here we write 1 minus row 1 and length of the interval, that is B0 minus A0. And here initial point is 0, and 1 minus row 1 is 5 by 8, here 5 by 8, and here 2 minus 0. So this equals to 5 by 4. This equals to 5 by 4. Okay. So now, what is the value of this point? What is the value of FA1? So here, if we're getting this value, this becomes 24.34. And here, at this point, your functional value at given point, you get here, this value is minus 18.65. Okay, so this implies here you see that f of A1 is less than f of B1. So this means your range is reduced. So the range is reduced to because A10 is less than, so that's why your range is this thing, that is A0 B1. Okay, so this is your range is reduced to A0 B1, that is you say that 0 to 5 by 4. Okay, so now in iteration 2, so now in iteration 2, okay, iteration 2, your interval are now this is A0 and this is B1, and that B1 A0 is 0, and what is the value of B1 is 5 by 4. Okay, and we take our point A1. Okay, so A1 and A1 value is equals to 3 by 4. 3 by 4 means 0.75, and this value is equals to 1 point something. Okay, so this means we this value is A1 is 0.75, and this value, if we half of that, so this becomes 1.25. This is 0.6. 0.6 is here. Okay, so 0.6 is here, and your value of A1 point is 0.74. So this is A1 point lies here. Okay, so this is your A1 point. This is your A1 point. Okay, but this point lies on right hand side. That we call this point is next point is B2. Okay, and here we have to obtain the new point, and that point we have to calculate it. That point is A2, and this point we have to calculate it. Okay, so now this value is equals to approx 0.6612. Okay, so now in iteration 2, we have to find in next row 2, because in first iteration you find row 1, and in next step you have to find 1 minus value of row 2, and this value equals to, here in formula, this value is f3 over f2. Okay, and this equals to 3 over 5. So this implies, what is the value of row 2? Row 2 is 1 minus 3 over 5, that equals to 2 by 5. Okay, so now what is A2? So A2 is initial point is A0, and row 2 factor and length of interval is B1 minus A0. So now A0 is 0. What is the value of row 0? Row 0 is 2 over 5, and B1 point is 5 by 4 minus 0. Okay, so if we calculate this value, this equals to half. Okay, and what is your B2? B2 is same point that is comes from the previous step, that is A1, and this value is 3 by 4. Okay, so here we have to obtain what is the value of functional value at A2. So F-A2 value is equals to minus 21.69, and here from here F of B2, this is same as the value of F of A1, and you have already find out what is the value of F-A1. This is minus of 24.34. And if we compare these two values, so you see that here your F of A2 is F of A2, or we say that F B2, this one B2. So this B2 is greater than, this is FA2 is less than F of B2. Okay, so your range is reduced. So range is reduced to A2, because here you see that your FA2 value is less than, so that's why your range is reduced to FA2 as greater than. No? Okay, so I think this FB2, this value is less than F of A2. Okay, sorry, because this is minus of 21 and this is minus of 24. Okay, so this is FB2. B2 is less than. This means your reduced range is from A2 to B1. It's not A0. This is A2 to B1. A2 B1 means this equals to A2. A2 means that point is half, and what is B1? B1 point is 5 by 4. Okay, so your range is reduced to this factor. Okay, so then we repeat similar process in iteration 3 and iteration 4, and then we will find our result. Okay, so next step, that is step 3. So on next page, so on next step, here was one thing is important in last step, that is step 4. That's why we will do all iterations 1, 2, 3, and 4, because in last step there is some concept behind in how can we do when this last step row 4 equals to half. Other steps, that is iteration first, second, and third, our row values row 1, row 3 is always less than half, but in last step that is equals to half. Okay, so next page. So iteration third. So in iteration third, we compute row 3. So we have to compute the value of 1 minus row 3, and that value is F2 over F3. and this equals to 2 by 3, 2 by 3. So now by using formula, we have find what is A3, B2 are same, that equals to 3 by 4. Okay, and what is B3? You can calculate and check that this is correct or not. Okay, this is B1 minus B2, and finally this value equals to 1 here. Okay, and what is the value of FA3? FB3, which is equals to minus 24 by 0.34, and F of B3, this value is minus 23. So if we compare these two, so we get our A3 value is less than functional value at 0.83. So this implies our range, the range is reduced to, sorry, reduced to this point, that is A2, B3. Okay, so this point is half and 1. So now main last step, and that is your iteration 4. So in this iteration, we choose here, if we choose our row 4, 1 minus row 4, and in this step you see that your formula is F1 over F2, and that's equals to half here. So half here, this means row 4 भी आपका क्या होगा, that equals to half. Okay, so here if you try to see this thing, here your point is A2 and this point is B3. Okay, and here and in between these two, your point is, this point is A3, and A3 point, this value of this A2 point is half, and this point is 1. Okay, and what is your value of A3? A3 is 3 by 4. A3 is 3 by 4. So here this point is A3, and that point is 3 by 4. 3 by 4 means approx 0.75. Okay, so approx 75 means this is half. Okay, हाफ है और ये 1 है, तो 3/4 तो इसके बीच में ही होगा. ओके, तो दिस मींस, so this point is in fact 0.5, this is 1.0, and midpoint is 0.75. Okay, and this midpoint is equals to your point, that point is denoted by point A3. Okay, so if we taking this row, उस केस में आपका क्या होगा, तो इस केस में आपके पास दो चीजें हैं. इस पॉइंट A3 को आप देखें, इस पॉइंट A3 देखें, तो हर बार फ्यूनकी मेथड में जो आपका लास्ट स्टेप होगा, उसमें जो आपके जो पॉइंट होंगे, दैट पॉइंट इन गोल्डन सेक्शन सर्च मेथड और फ्यूनकी मेथड में आप देखते थे कि ये पॉइंट आइदर राइट हैंड साइड होता था, लेफ्ट हैंड साइड होता था, डिपेंड, और जिस साइड भी होता था उसके अराउंड आप उसको चूज कर लेते थे. बट इस लास्ट स्टेप में आप देखोगे तो ये जो पॉइंट जो आएगा, से दैट इज फ्रॉम 3. ओके, तो यहाँ पे आप देखिए ये पॉइंट एग्जैक्टली मिड पॉइंट में आ गया. तो आइदर आप इसको क्या असाइन करें, हम इसको असाइन क्या कर सकते हैं, हम इसको कहीं A4 असाइन भी कर सकते हैं, और कोई स्टूडेंट इसको राइट हैंड साइड में इसको लेना चाहे तो B4 भी कर सकता है. ओके, तो अगर हमें इसको राइट या लेफ्ट अगर मूव करना है, तो अगर सपोज हम इसको इस साइड में लेते हैं, अगर हम B4 लेते हैं, तो इफ वी टेक B4 that equals to A3, this point equals to 3/4. तो उस सेंस में हमें A4 जो होगा वो हमें क्या होगा, स्लाइटली क्या होगा, हमारा राइट डायरेक्शन में होगा A4. ओके, तो A4 जो पॉइंट होगा, तो उस केस में अगर हम रो 4 को अगर हम हाफ ले लिया, एग्जैक्टली ले लिया, तो हमारा एग्जैक्टली वो पॉइंट फिर से कोइंसाइड कर जाएगा उस पे. तो दैट्स व्हाई वी टेक आवर फॉर्मूला A4 that equals to your initial point, that is A2, plus, yeah, we don't write here row 4, because if we taking row 4, so this point is goes to the same point. That's why we take some slight less than value of half. Okay, so this means row 4 minus epsilon. Okay, and then you take your V3. Case 2 places पे लेने हैं आपको. If you take epsilon equals to 0.5 0.01 value. Okay, because this decimal 2 point, so we take a small value of that. Either or you take epsilon equals to say 0.05. Okay, any values of that. Okay. So in order of that, in order of this significance. Okay, so if we try to solve this point, so then you get your A4, this equals to 0.725. Okay, and B4, this equals to 0. This 3 by 4, 0.75. Okay, then you have to find what is the functional value at A4 and what is the functional value at B4. So A4, you find this is 24.27, and at B4, this value is minus 20.34. Okay, so here the f of A4 is greater than f of B4, so your range is reduced to interval, and that interval are A4, B3, and that equals to 0.725 and 1. Okay, so here if we try to find what is the range of that interval, this is B3 minus A4, this equals to 0.275, and this is less than 0.3. So you have to obtain your result in this range, 0.3, and you find here your range is 0.275. तो ठीक है, तो इसके बाद है नेक्स्ट मेथड है आपका, लेकिन ओके, तो आज आपका टाइम पूरे हो गए हैं, तो आज इतना ही करते हैं। अदरवाइज हम नेक्स्ट मेथड भी सोच रहे थे कि बाइसेक्शन मेथड भी करा दें, कोई बात नहीं, तो आज के लिए इतना ही करते हैं। ठीक है, तो थैंक यू। ओके,
थैंक यू सर।